So here we are. This is a problem from a past exam, a chapter 3 exam. So f of x is sine squared of 2x minus the natural log of the sine of x. Very cool curve. What's the x value, Nargam? 5 pi over 3? 5 pi over 3? 5 pi over 6, sorry. So x is 5 pi over 6. Now watch what's kind of nice about the way I'm using Desmos here is that I can say, let me plot the point before I even find the point, right? Before I find the y value, 5 pi over 6, comma, f of 5 pi over 6. And so I'm kind of cheating a little bit of work there to see if I can find that point right away, right? So now I can see that point, and now I can just try and verify that I have the y value correct, right? So I guess another thing I would want to do is kind of put my scale in pi over 6. So I can just click on the gear, the wrench, right? The settings, and change my x step to pi over 6. You don't have to do this, but you'll see it will really kind of help. So 1, 2, 3, 4, I'm sorry, I said pi over 6, didn't I? Oh, 6 pi over 6 is 6 pi over 6 is pi, right? I don't know why I don't like that look as much as I thought I would. That's fine. There it is. That's better, right? If you zoom in a little bit, right, you can get the crosshairs where you want them. Nice. So let's get our derivative here, or the y value. We can do the y value first. Hey, Daniel, morning. So y is f of 5 pi over 6, which is sine squared of 2 times 5 pi over 6 minus the ln of the sine of 5 pi over 6. This is our first problem, Daniel. We're just doing a problem from an old exam. If you have one for me to do, send it to me, okay? So this is what? Sine squared of 5 pi over 3 minus the natural log of sine of 5 pi over 6 is positive 1/2, right? We agree with that? This is how I think about that. I cut pi into 6, which means the whole pizza into 12, and I count the 5th slice. 1, 2, 3, 4, 5. So it's this triangle that I'm dealing with right there, right? And so I know sine is positive there. I know sine of pi over 6 is 1/2. Sine of 5 pi over 3 is negative, so I get negative rad 3 over 2, but squared, right? Sine squared. And so what do I get? 3 over 4 plus the ln of 2. So that's how I prefer to write it, but you don't have to. What happened on that second piece? What happened here? I took the negative in as a reciprocal, right? It became an exponent. 1/2 to the minus 1 power flips, right? Don't have to do that. So let's find our derivative now. This one's tough. Let's see how you do. Find my derivative for me. And there's the derivative. Dogum, you had that, right? So let's find our slope now. Any issue with this part of the derivative? Anybody? Any issue with that part of the derivative? What's your thought again? U prime over u, right? So the u is sine. The derivative of sine is cos, so it's cos over sine, right? Which is cotangent. So what do I get here? 2 times the sine of 10 pi over 3 minus the cotangent of 5 pi over 6. So 10 pi over 3, I'm cutting my pizza, my whole circle, into 6. Double that denominator. And I'm counting to 10 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know it's negative 2 times the sine of pi over 3 minus 1 over the tangent of 5 pi over 6. I don't think in terms of cotangents. I think in terms of tangents. So minus 2 square root of 3 over 2 minus 1 over, what's the tangent of 5 pi over 6? Nice. On this one, I'd actually like to use the 1 over square root of 3 because it's easier for me to do the reciprocal quickly, right? So I get for my slope, I get minus square root of 3 plus square root of 3. There's where your issue was. You had the wrong slope. Dog 'em, yeah? And if you look at my Desmos, you can kind of see it horizontal there, right? So y equals 0 times x is gone. What's the y value again? Where did I get my value? 3/4 plus ln of 2, right? So you had your slope wrong. I think you had your derivative correct, but I think whatever you did in terms of evaluating the trig, you got that part wrong. But so what? It's kind of, so then what are you going to do on the test? You're going to not panic, right? You're going to not panic. You got it. You think you did everything right. In fact, you could check your derivative, right? You could check your derivative. So meaning what? Y equals f prime of x is Desmos doing the derivative, right? That purple piece. And then what do we get again for my derivative here? I'll use, well, where is it here, right? 2 sine 4x minus cotangent of x, right? Y equals 2 sine of 4x minus cotan of x. And it's exactly the same as the purple curve. So you knew that you had the derivative right, but when you did your tangent line, it wasn't matching up. So you knew you had to redo your slope. Just your slope part. You knew the derivative was right, but now you had to double check your slope, right? And you kind of want to use the graph as a hint. Oh, it looks kind of horizontal there, right? When I'm looking at that point there on the red curve, right? It looks like it might be horizontal there. So I know I should get a slope at 0. Or I know I should get a positive slope, or I know I should get a negative slope, that type of thought, right? Daniel, here is quiz solutions. And then our mock test for today and an old test from spring 2022. And then here is your quiz. Oh, maybe I don't have a quiz. Friday? Do I have a quiz for you? Okay, that's fine. Right now we have 9 quizzes. I'm hoping to get to 20, and I'll drop 5, is what I'm thinking. So if you miss a couple of Fridays, that should take care of the zeros. Just want to make sure you're getting better grades on the other quizzes. Yes. Yes. Yep. Yes, and it will. So sine of 10 pi over 6, right? Wait, what was it? It was 2 times 5 pi over 6, right? And I did sine of 5 pi over 3, right? So cut this one into 12, right? Double that denominator. Cut this one into 6. So I'm going to count 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sine is negative. 1, 2, 3, 4, 5. You see I'm at the same spot. Sine is still right. So I think about my trig a little differently than most teachers. The way they teach it is usually unit circle. I don't like the unit circle, right? But you think about it any way you want. So sine of 10 pi over 6 is the same as negative sine of pi over 6. So negative 1/2. Oh, wait a minute. So what I'm going to say is, because I'm just lost for a second, but I reduce it, and so then I'm talking about minus square root of 3 over 2, right? Which is what, 3/4? Yeah, so I'm doing something silly wrong. So let me just think for a second. Oh, we had a 4 in there too. I'm sorry, we had a 4 in there. No, yeah, but when I did it for my y value, right? I had a 2 in there. I'm just going to say, make sure you reduce first. Here is quiz solutions, mock test for today, and quiz, and I will be around today. Okay. No, so let me think about it because I'm confused. Okay, and you're bringing up a good point. I must be just thinking. I just it's maybe it's too early in the morning. I have to think. I can't figure it out right now. So, but thank you, Abigail, for asking, because I'm confused as well. I know it's something silly. Okay, so but we'll come back to it. Nice. Anything you want me to go over before we do our mock test? Anything else you want me to go over before we start our mock test? Sebastian, I have some stuff for you. Do you mind grabbing it for me? Quiz solution, mock test. Yes. Yes, question, Calista. It shouldn't have a trig in it. It shouldn't have a y in it. It should just be some expression of like a function of x. Okay. All right, let's start our mock test then. Here we go. Looking at, so what do I have, 6 problems for us to do? I can imagine your test being anywhere from 6. Oh, Lana, I have your material too here. Laura, Lana, quiz. Yes, mock and quiz solutions. Nice. All right, so on the mock test, let's do 10 minutes for number 1. Yeah, the first one. Yep. Yeah, I was still trying to fix my confusion on that. Sorry. But I'm on it now here. So this is problem, right? Mach 1. That's funny. Cotangent of x minus y equals x squared. I wonder if anyone got to the red box. Anyone get to the red box? Yeah. Oh, time's up. Remember what I said about these when I make these up. Typically, they turn out to be a little bit more difficult. So try not to panic too much. But it's still good for you. So I create my triangle right away, right? Derivative of I know derivative of tangent is secant squared. So derivative of cotangent is minus cosecant squared. I got it on my formula sheet regardless, right? I think after line 3, I think line 3 is fine for everybody. Am I right? Does everyone get line 3? Anyone get line 3? Yes, good. And then I'm just doing algebra for 4, 5, 6. For 6 to 7, I go back to the triangle, right? Go back to the triangle and get my ratio for sine. And then get an LCD in 8 to 9, right? But then I want to make sure that this thing is not factorable. I want to make sure that that's not factorable. How do I do that? Well, I start with just going to the curve, and I see it goes through -1. Do you see that? You see I have a root of -1? So I want to factor that. So what did I do? I did synthetic division with -1, right? And I got the factors of here and here. I don't think the other piece factors, but it does have, if I did ask for criticals here, there are roots there from the Pythagorean, quadratic formula. Question? Say again? Oh, the triangle. So cotangent is adjacent over opposite. So x squared over 1. Where is that? Say it one more time. Inside is alpha x minus y. So I could really think of this as cotangent of alpha, right? And so I'm just drawing a right triangle with an angle of alpha.
How did the 2x turn negative from 4 to 5?
So the 2x, I divided by minus cosecant squared. So the minus is there, and the cosecant squared turned into the sine squared. Nice. All right, let's do number 2. So I'm asking you to first take a natural log of both sides, simplify it, and then take the derivative, right? So on your mark and set, go. Mach 2. That's funny. No problem. I'm asking you to take the ln of both sides. If I don't, you don't have to. If I don't ask you, you still can. Right? So if I just read the instructions. So I take the ln of both sides and I simplify here to line 4. Is everybody okay to line 4? Everyone okay to line 4? Question? Yeah. Yes, exactly. We learned that the log of a times b is log of a plus log of b. So that's from pre-cal. We learned that. And it's hard to remember it all, but you got a formula sheet. Yeah, so the power, so we had log of a to the m is m times log of a. Is that what you're saying to me? Or you're saying where?
Like when you were doing the derivative from line 3 from line 3.
Right, but I haven't done a derivative yet. I'm just using the properties from pre-cal to write this as simple as I can. So I'm using two properties. Log of a times b is log of a plus log of b, and log of a raised to the power of m is m times log of a. I'm using those two properties from pre-calculus. Now I'm going to take the derivative of both sides. Right? And you see here I'm not in a rush here. I'm saying, okay, let me take the derivative of both sides. I haven't done anything, I just set it up, right? Now on the left-hand side, what do I get? U prime over u, so y prime over y. And on the right side, what's the derivative of the inside here? What's that derivative inside? -2 over the inside. What's the derivative of the inside here? 1 minus 2x over the inside, right? So you see how those derivatives become a lot easier, right? Because I'm kind of forcing that chain rule to become the pattern u prime over u. So much easier than what we were doing. Yes, so now I'm cross multiplying with the y, right? And I simplified the inside. Right? Simplified the inside as much as I can. I put in my y value, and I turned it into a quotient because that's what I felt like doing. Do I have to do that? No. You just have to do things that are correct, right? And so then I noticed that there's a factor of 2 that comes out, and then I got LCDs, right? So I want this as my LCD. And then the rest is pretty much straightforward until here. I want to make sure that doesn't factor. And look at what I did. I went to Desmos, and I graphed it, and I see that it doesn't cross the x-axis, so it doesn't factor, right? And then, of course, I could check it, right? I can check it on Desmos. Plot my function, plot y equals f prime of x for the Desmos function, and see if they match. Yes, where? So better than copying it is doing it over, right? On your own time. Do it over on your own time. As you're studying for this test, do this one over. This one's perfectly fair. I thought maybe number 1 was more difficult, but yeah, Sheila. Yeah, product rule or quotient rule, right? Okay, so let's Hosma, you still need me too. When we start this next problem, let's look at what you did on Desmos. Okay? All right, here we go. Next problem. I need a triangle on this one. Say again? Yes, thank you. Anybody get there? Of course, I probably made a mistake because I'm going so fast. The secant of the arctan of 2x over 3. And I notice I have an inverse trig. That means I have a trig. That means I have a triangle. I don't know if I need it, but I want to think that way anyway. And you'll see we'll be doing lots of these trig substitutions in Calc 2, okay? So then I'm taking the derivative. This is really now just secant of theta, right? So I'm taking the derivative. I get secant of theta times tangent of theta times the derivative of theta. Well, secant comes from the triangle, right? There, that ratio. Tangent comes from the triangle, that ratio. And when I'm doing the derivative of arctan of u, right? We have this written down. Y equals arctan of u gives me y prime is u prime over 1 plus u squared. So that's all I have to do is find u prime, find u squared, and plug in. So that's what I did here, right? And the rest is arithmetic or algebra. What? I got 2 times 2, that's my 4. 3 times 3 times 3 is my 27. I got an LCD here, and I'm doing 27 divided by 9 there. There's my 3. And then this little trick to get that is, again, this thought. Rad x over x is rad x over rad x times rad x. 1 cancels, I get 1 over rad x. Nice. Yes, Calista. Yes. Yes, so I have 4 over 27 times x times a fraction over fraction. So if you want to do the whole keep, change, flip thing, feel free. Again, you don't have to do your algebra the way I do mine. Okay? You just have to do things correctly. Yeah, so I got an LCD here, right? And why do I want to do that? Because I don't want fractions within fractions. I want a single numerator completely factored, a single denominator completely factored. Nice. We got 2 more to do. I probably won't get to number 6 today, but you certainly can do it on your own. So let's do number 4. And let's do 6 minutes. Sonia checked my work for me, and she said, "Do it over." Sorry, Mach 4 redo. I need another minute. Is that the derivative? Thank you. Slope, did we get a minus 11/50th? Okay. Anybody get the same slope? Yes? Thank you. Negative time quotient rule. You need that negative. The second piece is right. That piece should be have a negative out front. Remember, you're going to check everything on Desmos, right? It's good to check it as you go, meaning let me put this into Desmos before I do any more work, right? And then once I realize it's correct, I can then go further, right? All right, last problem, and we have only 7 minutes left of class. So here we go. Mach 5. Ooh, tough test, yeah.
Yeah.
Tough test.
Have a great day. See you Friday.